Look at the blue whale. At 100 feet long, it's the undisputed giant of Earth. But in the grand cosmic arena, it's just a microscopic speck. What if the universe harbors biological entities so massive they defy our comprehension? Today, we will explore the 4 largest alien lifeforms that could actually exist. Before we journey to alien worlds, we must ask, why don't we have mountain-sized monsters on Earth? The answer lies in a rigid rule of physics. In 1638, the legendary astronomer Galileo Galilei defined this rule, the square cube law. It is a fundamental limit on how biological structures scale up. Here is the fact. If you double an animal's height, its cross-sectional area, its bone strength, quadruples, but its volume, meaning its weight, multiplies by 8. On a rocky planet like Earth, if an elephant grew to the size of a skyscraper, its legs would simply fail to support its own massive weight. Gravity is the ultimate tyrant of biology. So, to construct a true cosmic behemoth, we must escape the solid ground entirely and find a different environment. Welcome to the realm of gas giants, exoplanets similar to our Jupiter, where the atmosphere stretches down for tens of thousands of miles without a solid surface. In these incredibly dense clouds of hydrogen and helium, the rules of the game change. Buoyancy becomes far more important than traditional standing gravity. In 1976, astrophysicist Carl Sagan scientifically speculated about giant floaters in Jupiter's atmosphere. Let's take his brilliant hypothesis and scale it up to an extreme exoplanet. Behold the first of our 4 speculative giants, the sky glider, a biological marvel perfectly adapted to ride the eternal cosmic storms of a massive gas planet. This isn't just a bird. It is a living, breathing aircraft carrier, a creature spanning over 3 miles wide, gracefully drifting through turbulent amber clouds. To avoid sinking into the crushing pressures of the lower atmosphere, it operates like a colossal biological hot air balloon, filling internal sacs with heated hydrogen. It has no predators, no ground to land on, and no need for heavy bones. It spends its entire existence in a state of perpetual majestic flight. But how does a city-sized entity find enough energy to survive in the cold upper atmosphere? Let's dive deeper into the biology of the atmospheric titan. To sustain a body 3 miles wide, eating smaller creatures wouldn't provide nearly enough energy. Instead, this titan harnesses the planet's extreme weather. Gas giants have colossal lightning storms, thousands of times more powerful than Earth's. The sky glider acts as a living biological lightning rod. It flies directly into the turbulence. Specialized conductive veins along its wings absorb the electrical discharges, converting them into biochemical energy. It doesn't live entirely alone. Vast schools of smaller, balloon-like organisms tether to its underside, creating a floating microecosystem in the sky. While riding the electrical currents, it also filters microscopic airborne organic compounds, similar to how Earth's blue whales filter krill from the ocean. With no solid ground to wear down its joints and endless energy from storms, a single sky glider could theoretically live for centuries. When it is time to reproduce, it releases thousands of buoyant thermal pods, drifting on the high-speed winds until they are ready to hatch. A majestic ruler of the sky. But to find our next behemoth, we must leave the clouds entirely and dive into the absolute dark. We journey from the chaotic gas giants to the silent, frozen moons of the outer solar system, places similar to Jupiter's moon, Europa. On the surface, it is a dead, frozen wasteland battered by radiation. But physics tells us a very different story lies deep beneath the ice. Tidal friction from the parent planet flexes the moon's rocky core, generating immense internal heat that melts the ice from the inside out. This creates a global subsurface ocean, potentially tens of miles deep. In this zero-gravity-like aquatic environment, biological size limits disappear completely. Water supports massive weight perfectly. So, what kind of monstrous Leviathan could evolve in a sunless ocean that is 10 times deeper than the Marianas Trench? Let's plunge into the abyss. Down here, there is no sunlight, no seasons, and no weather. Only crushing pressure and eternal darkness. Welcome to the domain of the second giant. A creature that uses the absolute darkness to conceal a body miles long. Without gravity restricting its weight, and supported entirely by the dense liquid, this creature can grow to a staggering 10 miles in length. Behold the Abyssal Leviathan, a majestic, elongated biological marvel that navigates the eternal night of this subsurface ocean. In a world completely devoid of sunlight, vision is useless. Instead, it uses these glowing bioluminescent nodes to communicate in complex light patterns. But where does a 10-mile-long giant get its food without plants or sunlight? The answer lies at the very bottom of the global ocean. Hydrothermal vents spew out rich minerals. Through a process called chemosynthesis, vast clouds of bacteria thrive here, creating a thick biological soup. Similar to Earth's baleen whales, the Leviathan uses hundreds of miles of delicate, specialized tendrils to filter thousands of tons of this microbial life. Because the ocean is pitch black, its brain devotes almost entirely to processing sound. Its echolocation is so powerful it can map the entire ocean floor. When it sings, it produces a low-frequency hum so incredibly deep and powerful that it physically warms the water around it. To survive for millennia, its metabolism is unimaginably slow. This heart, the size of a stadium, beats only once every 10 minutes. It is a gentle giant, serving as a moving habitat. Thousands of smaller crustacean-like aliens cling to its thick skin, traveling with it. Protected by miles of solid ice above, with a stable environment and zero predators, biologists speculate an abyssal Leviathan could live for 10,000 years. A silent, eternal guardian of the deep dark. But our journey isn't over. It is time to leave the comfort of buoyancy behind. We now travel to a super-Earth, a rocky exoplanet 3 times larger than our home, where gravity is not a suggestion, but a brutal, crushing dictator. Under this extreme weight, mountains cannot grow tall before crumbling. Any creature standing upright on 2 legs would instantly snap its own bones. To survive and grow massive here, evolution demands a radical solution. You must spread your weight across the ground. Enter the gravity serpent. Emerging from the intense, dust-filled storms of the super-Earth is our third giant, a creature that stretches horizontally for miles. Instead of fighting the extreme gravity, it embraces it. The gravity serpent distributes its colossal mass across thousands of sturdy, coordinated limbs. By keeping its profile completely flat, it eliminates the risk of structural collapse. In physics, pressure is simply force divided by area. Expand the contact area, and even the weight of a mountain becomes manageable. This evolutionary adaptation allows for theoretically limitless horizontal growth. Its body is heavily armored. The intense atmospheric pressure and gravity compress its biological structure, making its outer shell as dense as titanium. To fuel such immense mass, it consumes the planet itself. It acts as a biological strip miner, slowly digesting heavy metals and silicates from the rocks. Interestingly, the incredibly thick atmosphere of the super-Earth actually helps. It's almost as dense as water, providing a slight buoyant lift to the creature's massive body. Because sound travels poorly in the roaring wind, these titans communicate through the ground. They stomp in rhythmic patterns, sending seismic waves for hundreds of miles. These low-frequency vibrations are a unique form of geological language. A slow, ancient conversation echoing through the very crust of the planet. Just like our deep-sea Leviathan, this giant also hosts life. Tiny, flat, crab-like organisms live safely beneath its massive armored plates, sheltered from the crushing gravity. When it finally rests, it stops moving entirely. Over time, dust accumulates on its back, making it completely indistinguishable from a long, natural mountain range. A monument of endurance, a life form entirely shaped by the unforgiving downward pull of its home star system. But biology can be even more extreme. We have seen creatures of the clouds, the deep abyss, and the heavy earth. Now, we must travel to a place where carbon-based life simply burns away. Welcome to a tidally locked lava planet. Half of this world is frozen in eternal night, while the other half eternally faces a blazing star. The surface temperature here melts lead. Earth biology would incinerate in seconds. To find our final behemoth, we must completely rethink the chemistry of life. We have landed perfectly on the Terminator line, a perpetual twilight zone where the frozen night side endlessly violently clashes with the blazing day side. If we step fully into the day side, temperatures exceed 2,000 degrees. Here, the delicate chemical bonds of Earth's biology are instantly shredded. Every creature on Earth relies on carbon. So how could life exist in an inferno? Astrobiologists look exactly one step down the periodic table. Meet silicon. Just like carbon, it has 4 valence electrons, meaning it shares the rare ability to form 4 strong chemical bonds simultaneously. This means silicon can theoretically build the long, incredibly complex molecular chains required to create the foundation of a living organism. On Earth, silicon binds with oxygen to form rigid rocks and sand. But at 2,000 degrees, those rigid structures melt into dynamic, flexible fluids. This isn't purely science fiction. In 2016, Caltech scientists successfully coaxed living Earth bacteria to naturally create carbon-silicon bonds. Life can use this element. If nature had billions of years to experiment inside a vast, churning magma ocean, it wouldn't just create silicon microbes. It would scale up. Because liquid rock is incredibly dense, it provides massive buoyant support. A silicon-based creature could grow to the size of a mountain without collapsing. We are currently scanning the largest thermal lake on this hemisphere. The extreme heat distortion makes it almost impossible to distinguish rock from life. Wait, look at the center of the lake. What appears to be a massive, dormant obsidian island is moving against the magma current. Prepare yourselves. Rising from the fire is the final and most resilient giant in our universe, the majestic Magma Behemoth. Built entirely from crystalline minerals and dense glass, it has no eyes or mouth as we know them. It is a living geological structure. It doesn't eat matter. It wades into the deepest, hottest lakes, peacefully absorbing the raw thermal energy directly into its crystalline biology to survive. Instead of a beating heart, it has a centralized molten core. Liquid silicates circulate slowly through its body, acting like volcanic blood. Because it relies on the slow crystallization of silicon rather than fast-burning carbon, its entire metabolism operates on a geological timescale. A single step might take several days to complete. A single thought traveling through its crystalline nervous system could take years. Biology dictates that perception of time is linked to metabolic rate. A housefly sees the world in slow motion. But to the behemoth, we are the ones moving too fast. To this giant, human beings are just invisible flashes of static, popping in and out of existence in a fraction of a second. With a lifespan of potentially tens of millions of years, it is effectively immortal by our standards. It doesn't watch the weather. It watches geology. It stands silently at the edge of the Terminator line, observing the slow drift of the galaxy itself, watching constellations change shape over eons. When it is finally time to reproduce, it doesn't lay eggs. It simply sheds a glowing fragment of its own crystalline matrix into the molten sea. We have journeyed across the darkest corners of the cosmos, witnessing biology push to its absolute breaking points. We sought 4 distinct Titan archetypes, perfectly molded by the fundamental physical forces of their extreme environments. The Sky Glider, a biological hot air balloon, mastering the turbulent, bottomless skies of the gas giants. The Abyssal Leviathan, an endlessly elongated marvel of chemosynthesis, ruling the sunless, pressure-crushed oceans of ice moons. The Gravity Serpent, a flattened, armored crawler, conquering the brutal, bone-crushing weight of rocky super-Earths. And the Magma Behemoth, a crystalline mountain of silicon, thriving serenely in the eternal fires of tidally locked infernos. These 4 giants are purely speculative, but they are grounded in the very real, unyielding laws of physics that govern our universe. Whether life is made of carbon or silicon, whether it swims, flies, or crawls, the universe is a vast laboratory of infinite time and infinite space.
Vũ trụ quan sát được của chúng ta có đường kính lên tới 93 tỷ năm ánh sáng, chứa khoảng 2.000 tỷ thiên hà, mỗi thiên hà có hàng trăm tỷ ngôi sao. Với lượng không gian và thời gian khổng lồ như vậy, xác suất để sự sống, kể cả những cự thú khổng lồ, xuất hiện trên các hành tinh khác là vô cùng cao. Để định lượng điều này, năm 1961, nhà thiên văn học Frank Drake đã tạo ra một phương trình nổi tiếng nhằm ước tính số lượng nền văn minh ngoài hành tinh. Theo phương trình Drake, kể cả với những ước tính vô cùng thận trọng, chỉ riêng trong dải ngân hà của chúng ta cũng phải có hàng ngàn nền văn minh đang tồn tại. Vậy thì, tại sao bầu trời đêm lại quá đối tĩnh lặng? Tại sao chúng ta chưa bao giờ nhìn thấy một con tàu vũ trụ, hay nhận được một tín hiệu vô tuyến nào? Năm 1950, trong một bữa trưa tại phòng thí nghiệm Los Alamos, nhà vật lý vĩ đại Enrico Fermi đã đột nhiên thốt lên câu hỏi làm đau đầu nhân loại: mọi người ở đâu cả rồi? Đó chính là nghịch lý Fermi, sự mâu thuẫn khổng lồ giữa xác suất toán học cực cao về sự sống ngoài trái đất và sự thiếu vắng hoàn toàn các bằng chứng thực tế. Một giả thuyết đáng sợ để giải thích sự tĩnh lặng này là bộ lọc vĩ đại, The Great Filter, một bước tiến hóa khó khăn đến mức gần như không loài nào vượt qua được. Có thể bộ lọc đó nằm ở quá khứ, việc hình thành tế bào đa bào là một phép màu hiếm có, hoặc nó nằm ở tương lai, các nền văn minh có xu hướng tự hủy diệt trước khi kịp rời khỏi hành tinh mẹ. Nhưng hãy nhớ lại 4 cự thú của chúng ta. Có một cách giải thích khác cho nghịch lý Fermi ít bi quan hơn rất nhiều, đó là giới hạn về sự nhận thức của con người. Nhân loại đang cố gắng tìm kiếm sự sống bằng cách rà quét sóng radio. Chúng ta mặc định rằng người ngoài hành tinh cũng sẽ sử dụng công nghệ giống hệt chúng ta. Nhưng bầu trời có thể không hề vắng lặng, chỉ là chúng ta đang dò sai đài. Làm sao một anten vô tuyến có thể nghe được tiếng rung chấn địa chất của tam xà giao tiếp dưới lớp vỏ đá dày đặc? Hoặc làm sao chúng ta nhận ra được một lời chào từ tứ tượng, khi sinh vật silicon này mất tới 1.000 năm trái đất chỉ để thốt ra một tín hiệu ánh sáng duy nhất? Sự sống trong vũ trụ không có nghĩa là phải có hình dáng giống con người, sử dụng công nghệ vi mạch của con người, hay sống theo nhịp độ thời gian của con người. Giống như một bầy kiến đang cố gắng hiểu cách hoạt động của sóng Wi-Fi, vũ trụ ngoài kia có thể đang tràn ngập những cự thú vĩ đại, ngay trước mắt chúng ta, chỉ là ta chưa đủ lớn để nhìn thấy họ.
We return to our own tiny, fragile blue world, a single grain of sand in an infinitely vast cosmic ocean. We may never physically meet the Sky Glider or the Magma Behemoth. We might be trapped in the solar system for thousands of years. But we possess something equally miraculous. Inside the human skull lies a biological structure as complex as the universe itself. With roughly 100 billion neurons, the human brain structurally mirrors the vast cosmic web of dark matter holding the galaxies together. It is the universe's way of thinking about itself. And through the power of physics, mathematics, and engineering marvels like the James Webb Space Telescope, we can peer across billions of light years. We can analyze the atmospheres of toxic exoplanets and mathematically construct these alien giants in our minds. Until the day we finally receive a signal from the dark, our scientific imagination remains our greatest and fastest spaceship. The universe is infinitely wilder, stranger, and more beautiful than we can possibly fathom. So, keep your eyes on the stars, and never stop wondering. Thank you for flying with Scholar Bird on this incredible cosmic journey. If you enjoyed exploring the absolute limits of biology and physics, make sure to hit that subscribe button and join our space station. Which of the 4 cosmic giants is your favorite? The Sky Glider, the Leviathan, the Serpent, or the Behemoth? Let me know in the comments below. Until next time, stay curious, explorers.